Hello, my name is Balkrishna Pandey and welcome to this course CodeReady Container. At the end of this course, you will have basic understanding of what CodeReady Container actually is and how you can use this tool in your local development process. Course is a mix of slides, some infographics, and also hands-on demos to follow you along. You will also have access to my GitHub repository, which contains all of the information used in this course. Let's quickly go to the topic which I will cover in this course. We'll start with basic concept of what CodeReady Container actually is and what problem it's trying to solve. We'll install CodeReady Container in your local machine and explore all of the main commands of CodeReady Containers. After that, we'll install latest Openshift cluster using CRC, short for CodeReady Containers CLI, and also fine-tune your local cluster so that you can run extra workload depending on your need. Explore some of the concept of Openshift clusters to run the basic workloads, and we'll run a sample application also. Then we'll explore local container registry, build container locally, and push that image to local registry, and finally use that registry image in our project. Last but not least, we'll look at some of the troubleshooting steps in case your CodeReady Container and Openshift cluster is not responding. And if you get lost somewhere along the way, please leave a comment and I will do my best to answer your questions. Furthermore, if you want to learn more about CodeReady Containers, Openshift, Red Hat Service Mesh, or Red Hat products in general, you can contact me through my LinkedIn account, link in the description area. So what is CodeReady Containers? Simply speaking, it's a tool which set up Openshift cluster in your local machine. You can compare this tool with Minikube, which set up Kubernetes cluster in your local machine for development purpose. Similarly, CRC set up Openshift cluster in your local machine for development purpose only. You cannot use this cluster for production. This is not a production grade cluster, and you cannot set up multiple nodes also. It's just suitable for your local development purpose and for testing purpose only. Let's take a look at these examples. The way CodeReady Container work is it has a tool or binary called CRC. When you run CRC start, it starts a virtual machine, and on top of that virtual machine, it actually installs CodeReady Containers or local Openshift clusters. Once you have local Openshift cluster, it also installs internal container registry so that you can build Docker images or container images locally and publish into internal container registry. Once you have local Openshift cluster ready and the internal image registry ready, you can actually use OC or Openshift CLI to interact with the cluster and deploy your workload. You can create deployments, you can create a stateful set and daemon set, and simply run your workload in a form of pod. In order to install CodeReady Container, there are some prerequisites. For the virtual machine in which you are going to install Openshift, we at least require 4 physical CPU core, 9 GB of random access memory RAM, and 35 GB of storage space. This is just to run basic CodeReady Container. If you want to install more add-ons like Service Mesh and wants to run your workload, you have to bump these numbers depending on your need. On the operating system requirement, you can run CRC on Microsoft Windows version 1709 or more. You can run CRC on macOS 10.14 or newer, and the Linux and the officially supported version is RHEL and CentOS 7.5 or newer. You can, however, install CRC on the distro like Fedora, Debian, and Ubuntu with some additional manual code. Alright, let's start. To do that, you need console.redhat.com login username and passwords. So let's log into that one. And once you log in, you will see this dashboard. Click on Openshift, and from here, create the clusters. So there are different options you can use. For the CRC, we're trying to set up on local machine, so this is the only option valid for that. If you want to set up Openshift cluster on cloud, there are multiple choices here. Same is valid for data centers. You can play with all of these options. For now, we're just installing in local. So let's click on local and download the packages required based on your operating systems. So we have Linux, macOS, and Windows. For me, it's macOS. I'm going to download these containers. So let me double click on that. So this is a guided installer, and we're going to install 133.1 on your computers, CodeReady Containers. Click on continue. This is terms and condition. Let's accept that. And we're going to install for our users here. This is a default installation location. If you want to change, that's fine also. All right, so now CRC is installed. Now we can type CRC setup or CRC start. So it's already added on the path. So let me close it. See if I have access to CRC command or not. So we have CRC who's going to install 4.8.12, and we have all the command available also. So for this one, we just need to do CRC, I think, setup. All right, so it's already downloaded the HyperKit 4.8.12 bundle, and we can simply now say CRC start to start the clusters. So it's now creating CodeReady Container VM for Openshift 4.8.12. All right, so our CRC installation is complete now. I think it's created the etc host entry. Access this URL from here. And yes, this is accessible. And this is the, so I actually printed the username and password for the CodeAdmin. So we have admin permission for this. And we have user for developer also. Try to log into this user. You can say git POSIX, git parse -a. It cannot list the pod because I'm logging using developer user. So I cannot access to that. We can do something like CodeAdmin here. So these are all the components installed as a part of that. In this section, we're going to explore CRC console command. All right, now the cluster is up and running, and you want to do some basic operation on that clusters. So for example, you want to access the console URL. So there is a handy command called CRC console. And let me type the help menu for this one. So this is CRC console help, where you're seeing, and this is the alias. You can type CRC dashboard also if you want, and we'll print the same help menu. So what you can do is, if you want to open the CRC dashboard, CRC console, this is how you can open from the CLI itself. And this will open the browser here, or the Openshift local cluster in your browser, default browser. So if you want to print the credentials, if you want to view what are the credentials present, these are two commands you are seeing. Also login, and then for the developer users, username is developer, password is developer. So let's say copy this. If you paste it here, the username is developer for the developer user, and same is valid for CodeAdmin. The username is CodeAdmin, and password is this one. If you want to log into systems using OC command, you can do so. Simply copy this your command, paste it, and you have access to OC CLI. You can say git parse, let's say -a, and it will list all the parse present in this particular clusters. And same is valid for developer users. So if you want to see or login using developer users, you can do so. This is developer user. It's gonna work. It's gonna log in using developer user. Okay. If you just want to see console URL, you can do so using this shortcut. And here you can pass to your favorite browsers. if you want to view all the credentials in JSON format. And there's a handy command called crc console-output JSON, which will print the output in JSON format. And you'll see CSRT available for these clusters, your console URL, your URLs for the API URL, admin credentials, and developer credentials for this. If you want to add like log labels, as like debug info1 over here, you can do so. For example, you want to open the browser and then log label. So if you notice here, I'm using like this alias. So you can use either console or dashboard, both. It doesn't matter. Here you see more debug output. What's happening? The entire call. You can see the plugin service listing at the address. This one. So it's easy to debug, but just by saying this log, something is not working, you can add this log label, and this log label is valid for all the command, not for the console only. So if you want to do other, you can pass this log label. I already installed podman, so it will not going to install it. Possibly it will try to find the new version. If it exists, maybe it will update. You can see it found like a new version of podman here. I was running 3.4.0-2 and found the new one, 3.4.1, and it's installed now. So let me stop the previous version of machine first, and podman machine init. This is the next command you have to run. Let me see if I can delete it. So let me delete it so that we can do from start. So this is just deleting that podman machine init. So this will download the QCO image. I think it's going to download Fedora. It's already downloaded. Like I already have a cache. But if you look at here, this is the image it's going to utilize. Machine is in a slide, so you can do machine start info. It should print some output here. All right, so I have access to podman. So you can run like SC who am I to see which user you're logging. So you're logging using kubeadmin. This means you should be able to use podman login commands to log into to your local registry. So here what I'm doing is podman login kubeadmin using admin users, and I'm running OC who am I -t. So what this command does is like it will fetch the token. So this is a token we're going to utilize. And then we're going to use this local registry URL here, and this is our etc host entry pointed to local host. And I'm also saying TLS verify equal to false, so that it will not use HTTPS protocol. All right, so login succeed. Now we can create a new project called demo using our OC command. Project is created now using project demo, and we can try pulling some new image. Podman pull, let's say koi.io, and I'm going to pull the pod/alpine. It's downloading latest image here inside the VM we just created. And let me tag this alpine image, podman tag, and this alpine image with the registry URL. So here it's the latest, and let's do with that. It's under demo project. We created that project, and alpine latest again. And my assumption is I should be able to push this image directly to this one. But if you look at here, it's not able to talk to my TRC VM. So the case is we build that image, or we pull the image on podman VM, and we are actually trying to push that image to CRC VM, and it's not able to communicate with that. So to mitigate this issue, what you can do, CRC command, you can run CRC command, and there's a command called podman env. Let's run this one, crc podman env. So this is the command you have to export. You have to export all of these to your path and attach and container host as this socket URL also. So what I'm going to do is evaluate this command so that it will run this export here. You can directly copy paste that per command also, and see if I can publish this image now. All right, so at least it's not throwing the image error, and then it's now able to push that image to this registry also. Look at here, it's also get is, and then it's actually finding that image already published to this one. Is we can enable image lookup in the image stream, in this case our local registry. We can say set image lookup, that's command, and for the Alpine image just look up on the local registry there. This allows the image stream to be sourced of the image without having to provide the full URL to the internal registry. So that's the beauty of it. So you don't need to pass this entire registry location there, and I can simply say image Alpine, and it will actually find that in the local registry. Also, you run demo. This is the image name. We are calling it Alpine sleep 600 second. That will run for at least 600 seconds there. OC get parts, and it's running now. Sorry about that. OC describe part demo, and you can see here it's actually pulled from this location, which is running on the port 5000, so it's not living outside. In this section, I'm going to show you how to use CRC config subcommands to modify your virtual machine configurations. You can use CRC config command to configure both CRC executable and the CodeReady Containers virtual machine. So there are subcommand under this CRC command also. So let's explore some of the configuration options here. So if you look at here, CRC config subcommand is we have get, set, unset, and view. So if you look at here, view options. So view is basically going to show you all the parameter we configure for this virtual machine apart from default configuration. So it's not going to show you the default configuration. So if you look at here, I have configured constant telemetry to yes. You can set it to no, which basically means whether you want to send the uses data to the CRC developer or not. And then CPU configuration, which the default is 4, and I configure it to 6, and it started showing that. And the way you can do or set the, and this is one way you can view the entire configuration, customize configurations. If it is unset, then or set it to default, then it will show blank. If you want to know more about a specific configuration, so let's say CRC config get, and then you just want to see CPUs, right? The way you will do is you basically run CPUs, or if you want to see memory, you'll basically pass the memories. And this is the default value for memory, and it is not set. You can also run CRC config and do the help menu. So this is a help menu, which is printed, and these are all the configuration options which you can configure. So if you want to configure, let's say, proxy settings, you can set your HTTP proxy, and you can set your HTTPS proxy, and as well as you can say, okay, no proxy settings. If you want to customize your name server, you can simply say CRC config set, and that's another command which you can use to set or customize your configuration. And you can say, okay, I want to set the name server, and it can be 8.8.8.8 Google servers, right? I think that dashes maybe. And then you can view now config, and this name server is configured. There is another command if you want to unset this and roll it back to default value. You can do your CRC config unset and simply say name server, and it will unset that values. Now, if you look at the config view again, there is no name server here. So that's how you configure settings. And these settings will be applied when you start the VM. Of course, you can also customize that VM or override that settings when you start the VMs, just using overriding default configuration as a part of command line arguments. So let's say you want to pass name servers or override memory. You can do memory, and then you can use some different values, which should be greater than this one actually. So if it is less than this, I think it will show the errors. Oh, that's yeah, requires memory is 9216, so it should be greater than or equal to that values. So it has to be more than that. And I think and that is same is true for set command. So if you want to say set command and the CPUs to let's say 3, it will throw the error because the default is 4. So you have to be more than that or equal to that. So if you do 4, it will do nothing. It's actually roll it back to default, and then when you do view, it will not show up that value is there. So it has to be 4 or 5, and then let's say you can view the config like that. So that's how you can customize your configuration, and based on your need, let's say if your application, if your Openshift cluster requires more memory, more CPU because you are installing some other components and default setting is not enough, you can override the settings just by changing the configuration set commands, or you can pass that settings when you start the VMs. Since CodeReady Container is up and running, we're going to deploy a sample application. So for the demonstration, I'm going to utilize this pre-existing application called bookinfo, and this is to demo STO example, but I'm not going to deploy STO or service mesh as a part of this demonstration. I'm simply going to deploy this sample application. So if you look at the architecture of this sample application, we have a product page, which is a Python applications, and we have review microservices, which is Java-based applications, and we have Ruby-based application called detail page, and we have Node-based application called ratings. All of this application is containerized, and I'm simply going to consume the same containers. One thing we can do is pull that containers and publish into our local registry, so that instead of pulling it from upstream, we can pull it from local registry. So for initial demonstration purpose, let's pull the containers directly from upstream, and we will change our deployment methods later, or we'll publish that containers to our local registry and see if it will be reflected in our deployment or not. All right, so let's start. I already pulled these manifest files in my repository. So if you look at here, we have a product application definitions or manifest file, which has service object, and the application is running on 9080. Its label is product page, and this is a service object, and we have service account for the our permissions called bookinfo product page, and this is our deployment object. We're calling it product page -v1, of course, to demonstrate different version of applications using Canary or STO implementation. For now, we're not going to use STO, so we're simply going to use this name without changing anything there, because it's matching perfectly. So if I change it, then I have to change everywhere. All right, so and we are running this version of applications. Maestra example bookinfo product page -v1 version 2.0.0 running on 9080, which is pointed to service object here. This is our product page. Look at the rating page, our rating microservices. We have similar kind of object. We have service object, we have service account, and we have deployment sections here, again, which is pointed to ratings v1 2.0.0. We have reviews, similar sections. We have deployments, we have service account, and we have service here. Of course, we're calling it reviews. And the last one is we have detail sections. Same object, service accounts, service accounts, and deployments object. And we have like images pulling directly from upstream. Now I added one more component called routes, and this is Openshift awesome features. As soon as you add these routes, what CodeReady Container does is it will add or create etc host entry set for this one. It will automatically create bookinfo.apps.crc.testing pointed to 127.0.0.1. So look at here at the moment, let me do etc host create for bookinfo. We don't have anything. But as soon as I deploy this bookinfo application, it will automatically add that entry set here also, and you can access this application using this URL in your local machine without changing anything. All right, let's see. So for the demonstration, let's create a project called OC new project, and I'll call it bookinfo. And we have project defined bookinfo. I'm already switched to that project. Now I can simply deploy all of this manifest file. So this is my locations. I have bookinfo folder here, and I can deploy all of these components in that. OC apply, and do -f, and then you can simply do bookinfo folder. So it will create all these objects which we described before. Service account deployment for the details page, detail microservices, same is valid for product page, same is valid for rating page, and same is valid for reviews page here. And we have one more extra object called bookinfo routes. If I do get parse, I have all the application up and running with 23 seconds of time. All 4 applications is running. If I do get routes, I do have routes created automatically, bookinfo.apps-crc.testing. And if I cat that bookinfo, you can see this is being already added here automatically. So I didn't need to do anything at all. So it will automatically add to etc host, and then I can simply access that service from the browser or from the curl command. So let's try to access this one. So here it's actually returning response from that product page service. You want to open that URL here, you can also do so. And you can see, I mean, this is the default view. But here it seems up and running. I can see the reviews here. Absolutely fun, entertaining. And there is some booking details coming from details page, some from review page, review applications. So everything seems fine and it's up and running. So to run this application in this Openshift clusters, I had to do some configuration, though it seems like a little bit heavy application. It's not that heavy application, but it's actually causing some problem in our CRC cluster. So I had to adjust some configuration, which I did. If you look at the config view here, I adjusted the CPU, set it to 6, and then memory to 16 GB, and then it's perfectly up and running after that. Otherwise, it will shut down your... or otherwise I was seeing some intermittent issue with the Openshift clusters. It was shutting down time to time. In this section, we're going to explore some of the commands to troubleshoot your CRC Openshift cluster in case it's not running. CRC start. So the first problem we encounter is, let's say when you're trying to do CRC start, it's looking for pull secrets. And the way you can get this pull secret is just log into console.redhat.com. console.redhat.com and go to clusters, create clusters, and then you'll see this local options here, and from here you can copy these pull secrets. You can simply paste that and it should be able to create the Openshift clusters. If you want to clean up CodeReady Container, it's pretty simple. Just stop the CodeReady Container VM. This will stop the CodeReady Container virtual machine. To delete the VM, you can simply say delete, CRC delete, and this will delete CodeReady Container virtual machine. Since this is a disruptive command, so it's asking for permission. And you can clean up remaining resources just simply typing CRC cleanup. You can see here, these are the components it's actually removing.